let S1 be the set of complex numbers satisfying this condition that mod z is less than or equal to 5. S2 is another set of complex numbers satisfying this condition that imaginary part of this complex number, this is non-negative, greater than or equal to 0. And then S3 is this set of complex numbers satisfying the condition that real part of z, this is either positive or 0. Then we have to find the area of region bounded by intersection of these three, right? Area of the region S1 intersection S2 intersection S3. So first let us plot these three locus. One is mod z less than or equal to 5, another one real part of z positive, and third one imaginary part of this complex number positive. Then we'll see what is the common region in all three, right? What is the intersection of all three of them, so that from there we can identify the area that we have to calculate. So mod z less than or equal to 5, that is nothing but a circle with center at origin and radius 5 unit, all the points inside that circle. So the first locus is fairly straightforward. Mod z equals to 5 means points on this circle, either on the mod z equals to 5 means points on the circle, less than 5 means points inside the circle. So the first inequality will represent all the points which are either inside the circle or on the circle, center at origin, radius 5 unit. Third one is real part of z is positive, right? Third inequality, real part of z is positive. That means we are talking about first or fourth quadrant, right? In first and fourth quadrant, x will be positive. Real part of z positive means x is positive. So we do not have these two quadrants, right? I mean, if I take intersection of S1 and S3, then we have this half of the circle in first and fourth quadrant. But there is one more inequality here, that is imaginary part of this complex number should be positive. So let us try to separate the real and imaginary part, and then we'll see what kind of locus we are getting from here. So imaginary part of this complex number, and also you can see that these two terms are same, 1 minus root 3 iota divided by 1 minus root 3 iota. So we can separate these two. We can write z by 1 minus root 3 iota plus 1. This should be greater than equal to 0, and 1 is a real number, so you can uh, remove this one, because imaginary part of z1 plus z2 is same as imaginary part of z1 plus imaginary part of z2. So now we can write this as imaginary part of z by 1 minus root 3 iota, that should be positive. Z you can write as x plus iota y, because once we have an equation in xy, then we can identify the type of locus. And to separate the real and imaginary part, multiply and divide by the conjugate of this denominator. So this is the inequality that we are getting. And if we talk about the imaginary part of this complex number, imaginary will you will get when you multiply x with root 3 iota. So it will be root 3x and then iota into y plus 1. So root 3x plus y, and that divided by, in denominator you will get 4, right? 1 square plus root 3 iota square. So this is the imaginary part of that complex number, and this should be positive. So finally we are getting this locus root 3x plus y greater than equal to 0. Now this will represent, if I had equality sign here, then it will represent a straight line passing through origin, and the slope of line will be minus root 3. That means if I had equality sign here, then we'll get a straight line passing through origin. This is the equation of line root 3x plus y equals to 0. Now here we have the inequality that this should be greater than 0. That means it will represent any one side of this line. Either it will represent this side of the line or it will represent the other side of the line, right? Now, if I take any point in first quadrant, it will satisfy this inequality, right? If I take points like 2, 3 or 3, 4, any point in first quadrant, then it will always satisfy this inequality. That means this inequality will represent the this side of the line, right? The line in upper side, you can say. So now if I take intersection of all 3 points inside the circle, x is positive, so that means we are talking about right side of y-axis, and then we have upper side of this line. So clearly you can see their intersection will be nothing but this common part. Right? This shaded region will be the intersection of all three. It should be on right side of y-axis, so that means we have to neglect the other side. The point should be inside the circle, and also it should be on upper side of this straight line. So this shaded region is the intersection of all three. Now the question is how to find the area of this shaded region. So for that we need to calculate this angle, right? If I can find this angle theta, then we have standard formula for finding the area of this shaded region. Now remember, for this line, the slope of this line is minus root 3. That means the angle made by this line with x-axis, that will be 120 degree. So if this angle is 120 degree, the other angle will be 60 degree. That means this must be 60 degree. And now we can easily find this angle. This angle is also 60 and this one is 90 degree. So if I talk about the complete angle, it will be 90 plus another 60, that will be 150 degree. So now we can find the area here. Area will be half of, for area the standard formula will be pi r square and then theta by 360. Radius of the circle is 5 units, so pi into 5 square and then 150 divided by 360. Right? If I write in degree, then here the angle is 150 degree and total angle is 360 degree. So this will become 25 pi, and if we divide by 30, then this becomes 5 by 12. So finally this is 125 pi, this divided by 12. So that is option C, and therefore that will be the right answer for this problem. So in this problem, the important concept was to identify the different locus here. First one is straightforward, points inside the circle. Third one, this is also not difficult. X is positive, so first or fourth quadrant. And in order to decode this second one, in place of z, write x plus iota y. And if you can make this observation that you can separate one, then the calculation will be slightly less. Otherwise, also you will get the same result, but you will have to do some more calculation. So finally, we got this line, and now intersection of all three, that was this shaded region, and area of this region will be pi r square theta by 360. Finally, after calculation, we got option C as correct answer for this problem.